Okay, everybody, so welcome back. Okay, hope everyone's doing well and you did well on task 1 and task 2. Okay, so just again to reiterate why I'm doing this, okay, maybe something new to you having these pre recorded videos. Sometimes I think that mark schemes are a bit impersonal, okay, and they don't give you enough information. Okay, so maybe hearing me babbling on about moles in solution or whatever topic will help you understand the topic more, okay, in terms of the questions. Okay. So calculate the number of moles of H2SO4 in 50 centimeters cubed of a 0.5 moles per decimeter cubed solution. Okay, so in class we would have talked about N equals CV. Okay, N being the number of moles, C being the concentration, and V being the volume. Okay, and we discussed that V would have the units of decimeters cubed. Okay, and obviously concentration as always moles per decimeter cubed, and good old moles just mole. Okay, now in the questions that we're usually asked, okay, whether it be in an exam or even set by me in class, we usually have a volume given in centimeters cubed. Now we can't use this volume straight away because we need our volume to be in decimeters cubed. Okay, so there's two ways we can go about this. Oh, okay, flipped you all the bird. Okay, so 50 centimeters cubed. Okay, we can't use this directly, we need to be in decimeters cubed. Now, the way we can convert centimeters cubed into decimeters cubed, okay, to decimeters cubed is we can divide by 1,000. Okay, so what we can do, there's two methods to doing this, and I'm going to split it up. Okay, so the first method being you can convert the volume manually. You can do it straight away. You can just convert the volume. Okay, so 50 centimeters cubed divided by 1,000 will give us 0.0. It would give us 0.05 decimeters cubed. Okay, that's if you want to convert the volume yourself. Okay, and then you would just plug it in. So to calculate the number of moles, so N, you would times the concentration, which in this case is 0.5. 0.5. That 5 is looking a bit weird. 0.5, and you would times it by the new volume that we have. 0.05 decimeters cubed. And I forgot my units here, which are moles per decimeter cubed. And as a result, we would get an answer of 0.025 moles. Okay, now for those of you who don't want to have this extra step up here, so this step over here, okay, we can use the formula N equals CV over 1,000, and what we can do is straight away just plug our values in. Now the reason we can plug our values in is because it integrates, it takes into account this dividing by 1,000 step straight away in the equation. Okay, so how we had to manually just do it ourselves, 50 divided by 1,000, and then plug the values in. No, we don't need to do that. So this equation here will automatically convert centimeters cubed into decimeter cubed. Okay, and that's what we want. So I prefer if you use this equation. Okay, but this explains how you are getting this value and why you are converting from centimeters cubed to decimeter cubed. Okay, for those of you who are looking for a quicker way to do it, this is the way for you. N equals CV over 1,000. Okay, so N equals C, which is 0.5, times by volume, which is 50 in this case, all over 1,000. And what you will see is we get the exact same answer of 0.025 mole. Okay. Now I'm going to give you a chance, for those of you who didn't do question 2 or 3, to pause the video here and give it a go. Okay, so let's carry on. N equals CV over 1000. Okay, so N equals C, which is 0.2 times by 25, all divided by 1000, and that would give us 5 times 10 to the power of minus 3 mole. Okay, so that's some good stuff there. Now calculate the mass of, okay, now here we go. So now we're not calculating just the moles, okay, we're calculating the mass of potassium manganate that was dissolved in a 25 centimeter cube solution. Okay, as a result of dissolving this undisclosed or this unknown mass at this point, okay, because we haven't calculated the mass yet, so dissolving a particular mass of potassium manganate in a 25 centimeter cube solution, okay, to form a 25 centimeter cube solution with a concentration of 0.02 moles per decimeter cubed, okay, what was the mass that was needed to form this solution over here? Okay, now this is where it gets a bit tricky, and we have to combine our two equations for moles. Okay, now step 1, find the number moles. Okay, find the number of moles. Okay, so first what we've got to do is we've got to find out how many moles of potassium manganate is in this solution. Now we've got a V, we've got a volume, and we've also got a concentration. So what we can do now is when you see a C and a V, you should be thinking straight away we can work out the number of moles, because N equals CV, okay, over 1000. And as a result, what we can do is find moles. So 0.02 times the volume, which is 25, all over 1000. And what that should give us at this point is 5 times 10 to the power of minus 4 moles. Okay, now we've got our moles. Step 2, find the mass. Okay, so we know that moles equals mass over mR. And when we rearrange that, what we can get is we can find that mass equals the mR times the moles. Okay, now for those of you who might be struggling, you can go back to the class PowerPoint, or you can go back to the walkthrough for task 2 and explain how we can rearrange this, and maybe use a triangle instead of cross multiplying to rearrange the equation. Okay, so mass equals Mr times moles. Now one thing we haven't done, okay, is calculate the MR of potassium manganate. Okay, so I'm going to go up here to calculate the MR because I'm running out of space down here. So MR of potassium manganate. Okay, so the MR of potassium manganate will be, okay, 158 grams per mole. Okay, so that's the MR of potassium manganate. Okay, so if you want to go back and work, you want to see how I did that, find the atomic mass of potassium, the atomic mass of manganese, and 4 times the atomic mass of oxygen. Okay, so all that's left now is just to plug in some numbers. Okay, so mass equals the MR of potassium manganate that we've just found out, 158 grams per mole, times by the number of moles, which we worked out in step 1, okay, which is 5 times 10 to the power of minus 4. Okay, I always like to put my standard form in brackets just to avoid confusion over here. Okay, and we should get a value of 0.079 grams. Okay, so hope that clears up maybe some confusion on some of the harder questions. Okay, so it's combining our knowledge from finding the moles of a solution and then applying our moles equals mass over mr equation and then rearranging it to find mass. Okay, so as chemists you're going to have to do this sort of thing often. Okay guys, so probably getting sick of calculating moles and calculating concentration. So look, I've got 4 more questions for you. Okay, now again I'm gonna give you a moment, a chance for you to pause the video here before I start going through the working out. Okay, for question 4. Right, now I'm going to get into it. Okay, so again, this is similar, very similar to question 3. So they want us to calculate the mass, but they've also given us a volume and a concentration of the solution that was formed as a result of dissolving a specific mass of lead nitrate. Okay, so another thing, guys, because you are at the start of your journey as AS chemists, you need to get familiar with a few ions. Okay, so the hydroxide ion, the nitrate ion, so OH, so OH minus hydroxide, NO3 minus nitrate. Okay, so these are some common ions. Okay, but I digress, this is not the topic for today. Okay, so calculate the mass. So again, step 1, find the moles. Using N equals CV. Okay, in this case, N is equal to the concentration, which is 0.1, times the volume, which is 30. Okay, from the question. Nothing too difficult there, guys. Divided by 1,000 because we don't want to convert the volume by ourselves. We want to leave that work up to the calculator. Okay, and that's going to give us, bear with me. So that is going to give us 3 times 10 to the power of minus 3 moles. Okay, now step 2, like in question 3, was to firstly find the MR. Okay, so let's find the mass. Okay, using moles equals mass divided by mR. Okay, so find the mass using moles equals, so using, okay, grammar is not my strong suit. Moles equals mass over mR. So we're going to find the mR of lead nitrate first. Okay, now the mR of lead bromide is a whopping 331.2 grams per mole, and by applying our equation that we have listed here, moles equals mass over mR, and rearranging it, we get mass equals the mR times the moles. And because in step 1 we found out the moles, which was 3 times 10 to the power of minus 3, okay, we can just simply plug in some numbers. So our MR was 331.2 grams per mole. Okay, see, grams per mole. And our moles was 3 times 10 to the power of minus 3. And as a result, our answer is equal to, so I'm going to draw my answer all the way up here because I'm running out of space. Okay, Our answer, our final answer to this question was 0.9936 grams. But the likelihood is you'll be asked to give this to 3 significant figures, so your answer would be 0.994 grams to 3 significant figures. Okay, so that's that, guys. Now, question 5. What is the concentration of 1.5 gram of 1.06 grams of sulfuric acid in 250 centimeters cubed of solution? Now, little error here, guys. I've drawn it a bit. I've given it a superscript. Okay, but I wanted the answer in grams per decimeter cubed. Now, if you were in my lesson, you probably would have heard me banging on about units and how they're amazing and they can tell us what we need to do. Okay, so this is where understanding units comes in handy. Remember, so before I was writing grams per mole, I was writing it like this, but then I also said you could write it like this, grams per mole. Now, that suggests we are dividing grams by moles. Okay, so that's just a little a maths nomenclature. If you do a slash, it's usually a divide. Now, grams per decimeter cubed is suggesting we divide grams by decimeters cubed, so a mass over a volume. Okay, so you could also write grams per decimeter cubed like this with a slash instead of a minus inverse. Okay, so all you've got to do to find your concentration in grams per decimeter cubed is divide the grams, aka the mass, by the volume in decimeter cubed. Now, in this case, we've got a volume of 250 centimeters cubed, which is exactly the same, okay guys, as 250 divided by 1000, which is 0.25 decimeters cubed. Okay, then to find our concentration, so I'm just going to leave it as conc. Okay, we would divide the grams, which we have, 0.6 grams, up from here in the question, okay, 1.06 grams, by the volume that we've just converted to decimeters cubed, 0.25. Okay. And that would give us a value of, drumroll please, that would give us a value of 4.24 being a bit lazy with my units, so it's over decimeter cubed, so it'll be 4.24 grams per decimeter cubed. Okay, or again you can write it as 4.24 grams per decimeter cubed. Okay guys, now this question 6. Okay, now I purposefully said the word molarity. Now, molarity is just another word, so it's equivalent, okay, 3 lines meaning equivalent or the same as concentration. Well, it is anyway at A level, okay. For those of you who might want to study at university chemistry, you'll learn there's a slight difference between concentration and molarity. But for now, molarity and concentration are the same thing. Okay, so we have 15 grams, so we have a mass, interesting. We also have the chemical formula of the compound. So this is copper sulfate pentahydrate. Pentahydrate because that's 5. Okay, in 250 centimeters cubed of solution. Okay, and I want the molarity in moles per decimeter cubed. By molarity, I just mean concentration. Okay, got to make that clear. So we want our answer in moles per decimeter cubed. Okay, guys. Now how do we go about this? Okay, same way we would calculate concentration. Now, it's always good to write down the two equations for calculating moles. So we got moles equals CV over 1,000, and we've also got our friend moles equals mass over mR. Okay, again, these two equations need to be in your mind. Okay, so moles equals mass over mR. Now, we've got our mass. Okay, so I think it would be a good idea to calculate moles because we've got our mass. Okay, so it would be a good idea to use this equation, put it to use to calculate the moles. Now, we don't know the MR of this monstrosity here. Okay, so what we're going to do is we're going to find out the MR of okay, now the MR of this okay is 249.6 grams per mole. Okay, now I'll go through how I found that out. Okay, so the atomic mass of copper is 63.5. Okay, sulfur 32.1. 4 oxygens, so I would do 4 times the atomic mass of oxygen, which is 16, plus 5 times a water molecule. Now, you might want to commit this to memory as well. The molecular mass of one hydrogen molecule, okay, is 18. Okay, so oxygen is 16, and then 2 hydrogens gives you another 2 molecular mass, so 16 add 2 would give you 18. Okay, now adding this all up together, if my maths is correct, and if my ability to push buttons would give us 249 grams per mole. So that's how I found that out, okay, for any of you that were wondering, okay, because we haven't really come across something like this yet, okay. So then what I would do is I would calculate the moles. The moles would be 15 grams divided by 249.6 grams per mole, and that would give us 0.06 moles. Okay guys, and now we would move on to our second step, which would be to apply this equation here. Okay? Since we're looking for concentration, we would rearrange this equation. So what we would end up with is C equals N times 1,000. Okay? So N times 1,000 all over V. Okay, now you may be thinking, how on earth have I ended up with this? Well, if you look at this equation, I've simply just cross multiplied. Okay, so I've done this. Okay, I've got N over 1,000. Sorry, N times 1,000. I've ended up with N times 1,000. So I would have ended up with N times 1,000 equal to CV. And then what I would have done is made C equal to N times 1,000 divided by V. So I've just took this V over here, divided it, and what we've ended up with C by itself. Okay, so that's the objective of the game. If we want to find concentration, we need to have C all by itself. Okay, so C equals N times 1,000 over V. We know the moles, we know the volume, we just put them in. Okay, and because we've got time 1,000 involved and we've got divide 1,000 involved, we can just simply plug in the values. Now 0.06 times 1,000, and the volume that we've had is 250 centimeters cubed. Okay, ooh. Okay, so do excuse me guys, it's my first time using a visualizer. And that would give us a value of 0.24 moles per decimeter cubed, and we have achieved the overall objective. Okay, now this last one I've ominously labeled as hard. Okay, now this question, again, really revolves around having this weird unit of grams per decimeter cubed. Now, how many moles of sodium chloride are there in 25 centimeters cubed? Okay, so it's always good, volume. Okay. Now, this is a way of giving concentration. Okay, so this is a concentration in terms of grams per decimeter cubed and not moles per decimeter cubed. Okay, because concentration, again, guys, is essentially the amount of solute dissolved in a solvent. Okay, an amount can be given in grams, it can be given in moles. Okay, so again, concentration is the amount of solute dissolved in solvent. Okay, we'll speak more about that later on in the course. So V and C. Okay, but as you know, we really can't be using this. We need to convert this into moles per decimeter cubed. Now, so this question is not for the faint-hearted, guys. It's very unlikely that this would come up in your exam, but because some of the multiple choice questions in your exam, they bring in outside knowledge, so extra reading, okay, this sort of question could come up, okay, in that multiple choice section, maybe not in your full-fledged exam section, okay. So we can do this. N, do we know the number of moles just yet? No, but that's what we're trying to find. Concentration, we do know it, it's 50 grams per decimeter cubed, but that's not what we want. Okay, we want it in moles per decimeter cubed. Do we know the volume? Yep, 25 centimeters cubed. Now, how would we go about converting grams per decimeter cubed into moles per decimeter cubed? So, to go from grams per decimeter cubed to moles per decimeter cubed, okay, so grams per decimeter cubed to moles per decimeter cubed, we divide by the MR of the compound. So whatever the MR of the compound is, we divide by that. Now, the MR of NaCl, okay guys, is 58.5 grams per mole. Okay, so all we have to do now to find the concentration in terms of moles per decimeter cubed is do 50 grams per decimeter cubed divided by 58.5 grams per mole. And what we'll end up with is 0.8547 moles per decimeter cubed. Okay guys, so that's what we got when we converted it. Now, you may be thinking, why on earth am I dividing by the MR? The reason that I divided by the MR, guys, is because moles equals mass over MR. Now, we've integrated that into this. Okay, so originally we had grams per decimeter cubed, but to get to moles per decimeter cubed, we would have to divide a mass, which we did have, which was a gram here, by the MR. And we've cleverly, without doing too much work, gone from grams per decimeter cubed all the way to moles per decimeter cubed. Now you can see there's a significant difference in the number value. Okay, so this is our value in moles per decimeter cubed. Now I've sadly run out of some space, so I'm going to quickly grab some lined paper. Okay guys. Okay, so I found some piece of paper, guys. Okay. So okay, so now we've got our concentration that we need. Tick. Okay, so we've got a new concentration, which is this. And what we can do is we can set out our equation again. So N equals C equals V equals, okay, N is what we're trying to find out, so I'm just going to put a question, exclamation mark there. Our newly calculated concentration in moles per decimeter cubed, okay, is 0.8547 moles per decimeter cubed. And our volume from our question earlier on, we were told in question 7 that we had a volume of 25 centimeters cubed. Okay, now we have our values. So N is equal to concentration so N equals CV over 1,000. Okay, see, even the best of us we can make mistakes. Okay, everyone can make mistakes when it comes to this. N equals concentration, which is 0.8547 times by the volume, which is 25 centimeters cubed, all over 1,000. And with that in mind, guys, we would get a value of 0.02136752137 mole. But we're going to give that to 3 significant figures, so it's going to be 0.0214 moles to 3 significant figures. Okay, so that's a really long video going through those 7 questions. Okay, I've gone through them in as much detail as I could. Okay, and I'm looking forward to hearing your feedback. And for those of you who have made it this far, well done. Next class, I'll be looking forward to seeing what you thought of these videos and whether I should carry on. Okay, so goodbye, take care.